Yeah. So I think like you might have seen like kids playing with cars. Like they like the cars very well. Like, huh? Yeah. More or less more than video games. Like for the younger kids, if you see like around 2 to 3 years in that range, like they use like cars to physically hold and play around with that actually. Okay. So here the objective of this experiment is like what we are trying to do is we are trying the kids to see the numbers and like keep it in memory, irrespective of to know like whether it's 2 or 3 or 1 or something like that. This will be the very beginning. Maybe like kids of like age 2 or something like and all you can try this thing. Okay, so they won't be knowing the numbers, assuming that they don't know 1 2 3, like they won't be able to identify 1 2 3, and to them like you are teaching them like how to identify 1 2 3. That post to that beginning teaching, initial teaching, what you can do is you can take a cardboard, okay, and cut it like this sort of structure and keep one end opening. No need to be proper under, like it should be a like a tray kind of thing which with opening in one end, okay, and do some divisions with a sketch pen and write 1 2 3 till like whatever number you could able to write 1 2 3, and take some toy cars. In that also just put a sticker like with 1 2 3 and all, like so you collectively have the cars everything in one side, okay, and the cardboard setup in other end. You can ask the kids to play with that. So the condition would be like numbers should be matching. They'll be taking car number 1 and parking at the parking slot of car number 1. That's the objective. So I mean, if number of cars is more, they'll spend more time. If 1 or 2 cars is there, they'll finish it up soon and they'll look for the different work. So always try to keep as many cars as possible, okay, and this will like give the they can by doing this experiment they can recognize the numbers very well. They automatically start learning the numbers. Okay, instead of teaching like this is 1 and for pronunciation is different. First they need to know these are the numbers. For that, this sort of experiment would be really helpful. Okay, so the setup is just you need to have a cardboard and markings using sketch pen and toy cars. You can this number stickers will be readily available. You can buy the number sticker and fix it on the car and you can start using it.
Cars we need to buy those toys.
Yeah, will be you will get cars in like 10 set. It should be like as small as possible, not the big one. And try to keep all those even type of cars, like similar looking cars. Like the colors might be different, but it should not be like bigger one and smaller one. It won't be good. It will be confusing. Keep always even size car, yeah, and put a sticker on that and put a marker on the cardboard and you can start playing. So even that it's like without knowing the car, the initial motive will be like taking the car and just dragging it on the road. So this will be like you are just deviating their thinking little bit actually. They are already doing this work and you are just adding little bit condition to it so that they will start learning it. So this like it will be the car and one cardboard box, number sticker and the marker. The other task is like to network in telephone. Okay. Have you tried this thing?
Yes.
Can you like what we do is insert 2 cups in the string. Okay, so the length string should be length from here this corner to that corner. Okay, then we make like maybe some 2 or 4 and join together and insert. So one set I want. So you can take 2 cups and fill a hole in the bottom like this and insert a thread and put a knot and it should come out like this. So 2 cups, 2 similar cups should be there. output I need from 1 or 2 from 1 or 2 tests. They will trace the linear from this one to this one.
Okay. Two conditions. One, the string should be straight, okay, and then you should speak a little bit loudly. Actually, I should not hear it. She will be hearing. So that's it. That's so usually passing on some secret, right? So at least your friend will be able to hear it. So that much loudness it should be. Okay. Once you say that, she will be able to hear it. Okay. The condition is once the string is straight like this, she will be able to hear it. Ask someone to hold the string like this. Okay. She won't be able to hear it. Okay, that is the condition. Ask the other end to lower the string. It is the loosen string. You won't be able to hear it. These are the conditions you need to take it. So this only the regular one. These are the conditions. So then why it is not, once you get loosening, why it is not, why she is not able to hear it? That's the question you need to make it to the student. So doing this telephone is a regular one. The question is the one, like what your question is, that is the one which makes the kid to think differently. So, and the condition is once it is straight, then only you could able to hear it.
Yeah, we can hear it.
So the condition is this thing should be straight like this. That's it. Okay. And how it works is, and we no need to know how it is working, but the principle is, if the string is straight, whatever you are speaking there, it will vibrate this index. This vibration will get passed on this via this string, and it will vibrate the other end. Okay, that other end will act as a speaker. That's the underlying principle in the actual speaker itself. Only because the speaker is active. Okay, so this is the thing. Once you loosen it, this vibration won't pass on. It will end up stop here. So the other, it won't be vibrating in the other end. So it will stop the other end over the season. You can't able to hear it. So that's the principle behind this thing. So doing the experiment is the one thing. But you need to see more ideas and you need to ask questions. Okay, how whatever that if you speak like this, what happens? Or if you by holding the hand, holding the thing in one hand, you feel like what happens? Sort of that will discuss. Actually, these things should not be touching anywhere. Then only you could able to hear it. Whatever disturbance you do, if you think, you discuss the clarity.
Thickness of head doesn't
Yeah,
matter.
why did
The thickness of head doesn't
doesn't
matter.
matter.
So how you put the straw?
Just a knot. Instead of putting a knot,
Okay, no.
I am just tying it with a straw or a stick with a small stick or something. Since you need to hold it straight actually. If you are using knot or something, the thread will come out. Okay? Let's go to the next. Okay, we'll go to the next one. So another instrument is with ball actually. So kids like familiar with how they are familiar with ball, like almost all the people get exposed with some kind of volleyball or some kind of ball. So here like balls, you need to correct it. Okay, and some kind of balls could be like marbles, right?
Yeah.
That also, the marbles and some paperweight, all kind of paperweight will be there. Those things also you can correct. And you can just ready the ball and ask the kids to explore that. So one is would be like how far the ball is coming back. Once you bounce it, how far the ball is coming back. And you need to take care that you do not ask the kid to put a paperweight down, you do not break and sort of. That you need to take care. Okay. So bouncing experiment, how far the ball is bouncing up. So here also you need to ask the kid to predict it. But you need to work in his hands, like you need to ask him to predict which will come up, which will bounce high. If he says like this, you need to ask why. How? This is like why, how, and sort of you need to keep asking the questions. So ultimately it's later in answer like, no, this is big in size, or this is light in weight, or some sort of answers you will be getting. No need to be a correct answer, but you need to make the kid to think about it. And also like you can use smaller balls and have a tub, and you can ask the kids to put a tennis ball or put a marble in the tub, and you can ask them to check which is floating and so on. You can ask the kid to predict it. Okay. Some kids may predict rightly, oh no, this marble is heavy, it might go in directly. And also that if it is heavy in the matter, you can have a small marble and bigger ball. In that case, weight ball will be heavy, marble will be less compared to these two objects. Whereas you put a heavy ball, it will float again. You need to cross question the case actually. Each one is very correct, but that correct answer will be for the particular scenario. You need to create a new scenario where this condition, previous condition might get failed, and again like you need to learn something extra. So and also you need to say that why the football, like if there is a football and the marble you are using, football is heavier than marble, and why the football is floating on the water. Why? Yeah. Air is there inside the football, like which makes the ball to float.
Volume is more than the
Yes.
volume of the ball is more than the
Okay, that sort of things are a little bit complex. Okay, that we don't understand like what is volume. Even weight is a little bit tough actually. But that's why they are asking them to feel, and for us, like we say that definition, give a definition for weight, we will understand. You can't give a definition for a weight to kids. So we need to make them to experience that. Then we need to give a name to that. So it will be easy for them to understand it. Okay. So that's why like air one logic you can say that air is heavy. The thing is, the point is that whatever definition you are giving or whatever conclusion you are making, no need to be 100% correct. If it is related to that feeling, it's fine. The actual logic of floating the ball could be a volume or something to keep into a deep technical, but don't worry about it. Yeah, that is because of aerism. Something they need to do. Yeah, that's correct. That's not a wrong answer. That's correct. It's one way of answer. Okay. So, wall bouncing you can do, and stick experiment you can do. Okay. Then you can ask the kids to roll the ball. So which ball rolls like, which ball you could able to roll it further. So heavier one you could able to roll it further. The air like which is a lightweight ball, like you don't go further. So that sort of things are like, again like close to the rolling, you need to ask them n number of questions. Why you keep on asking, they will start thinking actually why it is running and sort of things. But we know the answer. Why it is rolling is air is there inside. But we need to bring the answer from the it itself. That should be our approach.
Sir, you said heavy ball will roll more, or light ball will roll
Yeah,
more.
heavy. To throw a marble, you can go as far as possible. You have to go maybe a
Throwing
football.
or rolling.
Rolling or throwing, more or less both are similar.
Because if we suppose if we roll a marble, that paper weight, if we roll a simple volleyball or beach ball, so I think beach ball will roll more than a paper weight.
That will stop soon actually, if you try it actually. More or less, this was similar to a balloon you can. You just throw a balloon out for it. So if you consider this as a model, you can throw, it will go through the area of the wall, but if you can't throw, you have to the wall.
For throwing, it's
Throwing, rolling also the same thing, you can roll this part. So heavy electrode that you are getting into D is not required for it. So getting into D, heavy things are, once you apply some force, it will retain the force for a longer time. Light thing that it will keep losing the force in soon. So that's not necessary for the equipment. Okay, this point, right? Yeah. This thing is like whatever there is a combination. These are the combinations you can do it. If you do a little bit systematic manner, you can prepare a table or okay, and you can have the 3 boards maybe, or if it is not in a position to read and you can put a pictures of the particular bar and ask the kid to predict actually. Will it close? Say yes or no, yes or no. So and then ask them to do the experiment. This just finding you need to do. So close to that, you can just do a weightage. Yeah, you just an appreciation. Okay, you have done it properly, or then it was correct. So this is again that this evaluation is nothing but an engineering. You are teaching the engineering. Okay. Another winter science activity is like in a windy day, if you over a scarf or something like it will be flying in one direction. If the wind is blowing in this direction, the scarf will go in another direction if you over it. So in big companies you would have seen that there is a wind direction is showing a device in the air on top of the company building and all. So that principle is similar to this. So you don't need to have a sophisticated wind direction to show in which direction the wind is blowing up. If you just hold a scarf or some kind of, just a scarf would be a scarf or a kerchief, you can use it. If you use it, if the wind is blowing, the kerchief will be moving in the opposite direction of the wind. So you can say that in the case like wind is coming from this direction. So even like if you ask the kid, like if you keep a fan and if you show a scarf like that, it will go like that, go in the opposite direction. If you ask the kid will immediately answer for this question, yeah, wind is coming from this direction. It will immediately answer. But they won't be able to justify why it is coming. So for that, you need to ask the question, why? How you are saying that the wind is coming from this direction? So that's the kid will say that the air from this direction is pushing the scarf the other. Some sort of explanation you will start getting that. Okay. This is a windy science activity. Another one is cloud experiment. Here like the components required for this is a clear glass, the water, and a shaving foam, okay, and a food color, liquid food color. So normally like in the clear glass you can fill the water for almost 70%, okay, and if you put a shaving foam, the foam will start floating under water. It won't get mixed easily. It will start floating. Okay. And if you notice properly, the foam is not a solid, not a liquid. Like it's nothing but a mini bubbles combined together, and that's the structure. If you put some liquid on top of it, that liquid weight will be heavier, so it will directly go down. Okay. So this is not the exact cloud experiment or something like that, but it's like you are using the kid to think about, okay, cloud looks like this only, white color foamy substance it is there, and the water droplets are coming like this. If you put a liquid food color on top of this, the liquid food color will penetrate through this foam immediately, and it will just mark some colorful lines in the display. So the kid will get attracted to these lines and other things that are, but underlying concept is you can relate this experiment to a cloud and rain experiment. I think. Yeah, clouds are like this, and once it gets condensed, it will get converted into water, and water droplets will go like this. This is like a running experiment. It's a real time, but it's not the actual. If you see literally, this is not the exact raining process, right? Raining process is different, but this is like you have something to visually show to the people. You can gain the interest of the kids by showing something different. Yeah, some foam is there, put some color, if it is find color patterns, it will attract them very much. Post that you can start your actual rain experiment. Okay, this could be for attracting the its focus towards yours to teach something to them. Okay. Then you can start the actual rain experiment. Okay. So this experiment setup is simple. You can take one transparent water. Okay. Which you should take some, I think half of the part should be containing some hot water. Okay, hot water. And you can have a bowl on top of that, which you can use it as a lid. Okay, it could be a plastic or a metallic bowl. Okay, and you need to put some ice cubes inside the bowl. Ice cubes. So I think this everyone will be aware of this experiment. Yeah, since the water is boiled, it will be keeping evaporating. It will be emitting to whatever it is. So whatever water is coming out of this hot water, it will be going up and touching this surface. This already since you get some cubes inside that, the vapor will get immediately melted and you get the rainy droplets. So this is the actual experiment. Actually, this is the exact equivalent representation of a rainy day. Okay. So if you do the previous some experiment, you need to relate like this. If you do the previous experiment, it's not the actual representation, but it attracts the rays and it focus and give some kind of basic idea. Yeah, some like this, some sort of thing. Most people you can relate to that. Yeah, this is a cloud kind of thing, and whatever like from sea, all the water are getting evaporated and goes and stays as a cloud on the top. And you can, you'll be having rhymes for that and stories for that, similar to cricket. This and one more point I want to mention is this stem. It's not only experiment. You can add your poems like rhymes and stories along with it. Similar related to that, you can add a rhyme or you can add a story along with it. Okay? Then don't misunderstand, just know it. Pure experiment is it. No, it's not like. You need to convey the same concept, but it could be in any way. Or if you along with an experiment, if you are integrating a rhyme or a story, that is relevant to that. For the catapult, if you tell some other story and there is a theme story and do some kind of iteration, then it will be like very relevant. They can relate it. So initially, we ourselves is not able to relate what is catapult. So we start with the story and then you can just get going. So this is clear, right? So this is the float experiment. So now cyclone kind of effect you can show it, you can simulate and show it to the people. So the required things is like you need to have a clear process. Okay? And we show for any soap that you could be able to generate foam once you take it. Okay? And our water. So in a clear water, you take almost 100% of water. Okay? We mix the soap to it and shake it up. So that this particular portion will become a little bit misty white color. It won't be too white. Little bit misty white color, the water will get changed. And once you shake the bottle like this in this sauce and leave it there, you need to shake it for a while. In the soapy water, this part will be foam and this part will be the water. So it will look like an actual tornado that cyclone. And again, in this, you need to start asking questions to the student. Why this like foams are on top, sort of thing. It's not need to be cyclone related question. It could be why the bubbles are on top, sort of thing. And for attracting the fish, this will be a good. animals and plant structure. Or if you have some small toys, animal and plant toys, you can put those toys also inside that. And you can say that no, yeah, due to cyclone, that the plants are getting, plants and animals also that rotating along with the cyclone, sort of things that are. It's like you need to keep scaling it up. Based on your creativity, you can keep changing all the experiments. One more candy experiment. Here, like, one more experiment is, one more candidate experiment is like to know which candy will float or sink. Okay. For this, you can prepare a shot like this. You can take from 4 different candies or 5 different candies and prepare a prediction test whether it will float or sink. And what is your observation? Post to the experiment, what is your observation? That you can put it in the other part. Okay. Here, if you take the candy, it will be in a different part. One is like it is a pure chocolate, okay, and that will sink. Okay. Wafer is there, some chocolate, some wafer in between, and chocolate covering will be there on top of that. Those things like wafer is nothing but it contains lots of air bubble inside. So if you put the candy inside it, though it will look heavy and it looks like a something, but if you put it in the water, it will float. Okay. So that with the candies you can do this sort of experiment. You can choose the candies accordingly. You need to choose 2 candies in such a way that it will float, 2 candies in such a way that it will change. So once you run the show, then so this is also like making the to think like why it is floating, how it is floating. And once it is floating, you can do the similar candy to the kid and ask them to open and see what is there inside, what is there inside. They should be able to compare and answer to your question. Okay. Any doubts in this? So I think that everyone can explain this. And what are the cables? You can use different vessels and give the same amount of water. You can ask it to fill it with a different vessels and make them to analyze like how it is reacting. So, I mean, it's like again there's another question. This is like diameter wise it's very thin. This diameter wise very big, lengthy. So what happens is once you fill the same amount of water, you see the height, but this is showing lesser height, this is showing more height. And the quantity is same, but you need to ask the question like now which is containing more water. If you using the same amount of water to pour in both the vessels, pour to that one will be showing at the top, I mean maximum height. So by asking the question, he will say definitely this is the one which has more water. So then you need to relate the diameter dimension to them. So only this dimension, they will always give this scenario to it. It will just say that whichever is having more head, that then says this is the vessel which is having more water. Okay. So this process, based on the questioning, we can just mix and create n number of scenarios for it. And one more thing is like also this is leveling, and leveling is kind of scenario. And one more scenario is like the actual scenario is water is shapeless. Water, whichever container you are pouring the water, it will change its shape accordingly. So while making the experiment to the kid, like we need to keep in mind that kids can't relate a longer, they can't do a long duration experiment. Whatever they want to do, it should be like they should be able to pick the, they should be able to see the result immediately. Okay, and it should be interesting to them. Okay, if it is a longer, if it is a, there is an experiment which is goes for a longer duration, definitely you need to keep in mind for the, 6 years old, maximum age old kids only. Okay, here in this container, we will be taking 2 containers. bottle, you can use a bottle also for this, which is transparent, and you can take the same amount of water in day one, okay, and once at a time you can pick a marker or write using a sketch pen, you can just make a marker, okay, and you need to close one bottle also with a cover and tie it properly without the air, like there should not be air inflow or outflow from this container. Okay, it should be closed properly, and you need to leave the setup for at least 1 week or something. Post that you can notice that whichever the vessel is open, its water level would have been reduced. It's nothing but because of the evaporation process. Due to the environmental temperature and changes, this water will slowly start evaporating. But this is not a short period of experiment. It will go for at least 1 week or 10 days is required to see the result. So for this sort of experiment which you are planning, similar to this experiment would be like if you put a polythene cover over some set of leaves in a plant and tie it up, right? Post to 1 or 2 days you can see the water droplets in the cover, polythene cover. Okay, that also long duration experiment. That also you need to avoid giving those experiments, showing those experiments to the kids for the younger kids like 2 years or 3 years old kids. So another colorful experiment would be like oil and water. Okay. For this you can use food color. Okay. And initially what you can do, you can take a container. You can fill half of the container with water, add some food color to it, do some attractive colors, like some bright colors and should be attractive, and use the color and stir it well so that water color will get changed. And then use some oil. Mostly try to use some kind of cooking oil. Don't use kerosene and sort of thing. Since kerosene can be used here, but it's not safe for the kids. So whenever you are planning for any experiments for the kids, don't use any dangerous things. If you are using, even if you are using things also, like let it be under your care. You should be monitoring them. So when you are using oil, try to use a cooking oil. Any cooking oil could be used. So cooking oil normally will be yellowish or whitish, and the other color will be contradicting. So you can ask the kids like, what is this? Whichever is floating, what is that? Whichever is what is that? Why it is floating? Okay. So this is like if I ask you like why the oil is floating on the water, you say that oil density is less, the oil weight is less. So it's floating and production will keep giving that. This answer needs to be brought out from the speaker. Okay. And also you can try mixing the oil and water. Even if you stir it properly, by closing on the top, if you are using a bottle, closing on the top, if you start mixing it and if you leave it for some few seconds, it will again regain its original position. While mixing it, the color mixing and all, like it will look good at it. It will attract the kids. And then once they start looking at it, then you start asking the question. Dust can float on the water, right? Okay, it swims like almost like majority time that spends on the water. You know, like why its feather is not getting wet? Whatever you put it in water, it will get wet normally. Why its feather is not getting wet? Sorry?
Oily.
Okay. I mean, you are saying that would be a oily or a lactic substance on the feather. Who is applying that?
No,
Okay, fine. Any other answer? Okay. Yeah. Good. Okay. Actually, if you see, normally you would have seen that's like while it is doing majority time, it will be like with its beak, it will be always like doing something with its feather. you usually keep to, and you do some movement from here to the end. Actually, what it does is it goes body to secrete some kind of oil. Okay, this will secrete some kind of oil which will be that oil will be used by the, like you are sweating, right?
So that's giving so much info, like I'm not able to. That's it. Okay. So if you use like we are sweating, right? If you are standing in the sun, similar way, the birds will sweat. There are some glands in the bird which will segregate oil substance, and that will be like as a sweat. It will be in this in the skin layer. Okay. It will the bird uses its beak to spread this oil from this root to all the parts of the feather. Actually, that's how it will keep. It will mostly, if you notice the birds, like notice the duck, it will keep on doing it. Often it will be doing this process actually. So and moreover, like this oil, what it makes. So in the previous experiment we have seen that oil and water is not mixing. So and if you quote what about like the scenario is like, can you make a paper which is not getting wet in water? You can just give a paper to the kid and you just ask them to soak it. Yeah, ask them to check whether it got wet. And the other scenario would be like, can you make a paper which is, or can you make this paper not wet in water or something like that? You can just start creating the task like that. So kid you need to create a scenario in such a way that kid need to relate to the previous experiment. If I do something with the oil, with this paper, if I add some oil with the paper, will it float or something? They should be able to they should be able to attempt this approach actually. Till that we need to give our like flow actually. So the actual scenario is you can ask the kid to do that experiment. Okay, the normal paper, ask them to dip it, yeah, it will get wet. Dip it in oil, then dip it in water. It won't get wet actually. So you can relate to the birds, the duck relations and all, you can do it here. And also here, if you are using a story or a rhyme, you can just insert a duck story, like which a floating kind of incident or something like that. You can insert and merge both the things. So this is another water transfer experiment. Here, like you can take some maybe some 4 or 5 bowls, or at least 3 also should work. Okay, at least 3 plus bowls you need to take it up. If you work for this experiment, try to use transparent bowls so that the kids can see the colors whatever is there in the bowl actually. It could be, you can use the opaque also, but if it is a transparent it will be good. Okay, and use different colors. Maybe you can use a food color, take some little bit water, maybe 40% of water, add different food colors for each of the vessel. Okay, you can take a tissue paper, okay, and fold it like this way and dip it in both you arrange the bottles in the sequence and dip it like this. Okay, here this color will increase some, if it is a yellow, this part will be bright yellow. If it is an orange, this part will be bright orange. The joining part will be mixture of yellow and orange. It might be a different color. Okay, or you need to choose the color in such a way that if you are using red, green, blue, it will give a very good difference. Red and blue will create one color which is entirely different from red and blue. Here as a blue and mix of blue and green will create a different color which is entirely different from blue and green. So here, you can ask the kid, the color is here only, how it is getting transferred. Since the paper is absorbing the water, the color is getting transferred. Here there is in the bottom, it is in both the bottom it is different color. Why on the top it is creating a new color? You can start asking here the mixture of red color is getting absorbed here and green color is getting absorbed here. Mixture of this creates a magenta color or something like that. But if you use a RGB, it will create a CMY, cyan, magenta, yellow. This will give an entirely different color. That's what, like, to make the kids to visual. Here in this picture it's yellow and orange. It's not that right mix. But when you are doing it, if you are using RGB mix, it will give a good result actually. So here different color, here different color. In the mix you will get a different range of color. Cyan, yellow, magenta. Cyan, CAYAN, cyan. Yellow, magenta, yellow. Here, like under the science section, you can go with a bean seed dissection actually. So that is like, you know that you can take any one big seed actually, be bean seed or I don't know, like there will be some seeds of this. Yeah, you'll be using bigger size seeds, no? This much big it will be. That sort of seeds you can choose and soak it in water, and once you isolate it, the inner part will be like this. There will be a tip kind of thing here, that's nothing but embryo and 2 cotyledon. Okay, this you don't need to explain the concept, you don't need to make the kids understand this thing since it's too far for them. Just you need to expose this thing. Yeah, you can open the seeds. So whenever they see a new seed, they'll start opening and they'll start exploring what it is. And so for that, we are giving this scenario by taking a big seed, we are opening it and we are showing them these are the parts and sort of thing. If they understand, it's okay. If they're not understanding also, it's not an issue. We are making the kids to do this sort of experiments on their own. So another candy recognition game. For this, you want candies and alphabet cards. Okay, you can arrange the alphabet cards and give the set of candies to the kids. And with the starting letter, if the candy is starting from the whatever starting letter is there in the candy, you need to ask the kid to arrange it in the appropriate alphabet. Okay, it's more or less like for the numbers we are using the card game, right? Similar to that, this is for the alphabets. Okay. So one more experiment is like electrical energy. Like we need to give some basics about like electrical sort of things also. No need to be in depth. We need to give some little bit safe hands-on stuff to the kids actually. Hands-on means here, like in this scenario, what we are planning to use a battery and a LED and some kind of connecting wires. Okay, so once you do the connections properly, it will glow the LED. The concept is simple. Okay, so this is the actual scientific concept. This we are planning to explain to the kids in a simpler way. For that, what we are planning to do is so I'll be giving you a battery and an aluminum foil and one LED. Okay, what you need to do is you need to take a chart. Okay, in the bottom you need to paste the battery. You need to use a cellophane tape to paste the battery. Okay, and you need to I'll be giving a aluminum foil. You're aware, right? What is aluminum foil? For packing the foods you'll be using, right? That aluminum foil strips I'll be giving it. So aluminum is a conductive. That is a conductive. If you keep it near plug and all, you will get shock actually. So using wire is not safe for the kids. Like the wire will be having that metallic threads outside, so it'll penetrate with the kids' hand and very easily. So it's not safe to use wires. So I'm using aluminum foil for that. Even they eat also, it's not so dangerous. It's a very thin material. Okay. So you need to paste the aluminum strip like this actually. So you need to put one more tape here and another tape with I'll be giving an LED which will be having two LEDs. You need to keep the LED in one side and put a tape. Here put a tape and again one more strip. Put a tape. Are you got it? Or if you have any doubts, you just ask me now itself. See, you need to cut the chart. Okay, maybe 1/4 of the chart you can use it. Okay, in that you need to keep the battery. Will be giving you a battery. You need to paste the battery first using cellophane tape and using aluminum foil. I'll be giving you a foil, aluminum foil kind of thing. That you need to paste it like this actually. This pasting also you need to do it using cellophane tape itself. Okay, and the other two ends you need to fix a LED. I'll be going step by step again. So this as a overall I'm telling you these things actually. You got it now?
can stick the battery like this. At the bottom, yeah, you can stick it like this. Don't paste it. I'll tell you how to paste the aluminum foil.
How many we need? 2 each. 2 each. I not sure.
Just paste the battery alone. Don't paste the foil. No, you'll be getting it. No, don't. You'll be getting it. Maybe if you want, you can fold it like this.
You fold up. Fold up.
Yeah.
That machine will do.
Yeah.
Yeah, you can take this.
No, don't cut it. You're folding it to get rid of its stiffness.
Okay.
So others will be getting the foil. Whoever is asking, just fold it up. So you get a thin one like this. made a hole, right? So yeah. So you need to, this is a completed one. So one end you need to put a tape. You need to take one end of the coil and put a tape to the one end of the battery. Take the other end, put a tape to the other end of the battery. Okay? And put the tape in between. Both the coils should not touch at all. This coil should be isolated, it should not touch. Okay? It should be isolated, it should be parallel like this. If you want that, you can use a number of tapes in between, but it should be clearly isolated. Okay, so once it is, you need to just tape the two ends right now. Using silicon tape, tape one end here and other end here, and keep a parallel line there. Okay. This thing should not be touching, right? You just put a tape. Yeah, fine. You can use the smaller one. One is good enough. Okay, the objective is that you are doing it on your own here. That's it. And one more thing is, this is not for a small kid. For a age group of 5 or 6, you can show this. This is not, you won't be asking the kid to do it. This experiment will be done by you and you will be demonstrating to the teacher. Once it's proper, LED will be closed. So here nothing like LED, you need to give a power supply. The power supply is coming from the battery. Instead of wire, you are using this aluminum foil. So it is safe for a kit like if you are using it to wrap up the food material, it is pretty safe. Sorry? Okay, I'll come to that part. See, one thing is first step, the second step is just fix the aluminum foil. If it is done, let me know. Oh, there's one to come later. Take the release and just split the wheels apart. It will like this. Okay? And I'm not, I didn't ask you.
Okay.
Just split it apart. And before fixing the LED, you need to keep the LEDs on the coil and set it. Make sure that one main will touch in one coil, other in another coil, and check it whether it's flowing. Okay? That is the right direction. That direction should not change. In the same direction, check it as a check.
Sir, on the silver finger we keep this one on the silver finger.
Yeah, yeah, it should be like this. First you need to test it. Don't place the LED before testing. You need to test it by keeping on the foil like this. If it in one direction it will glow. If it is not glowing, reverse the direction and check whether it is glowing.
None of the directions it's going.
There will be
It's not proper, no? Maybe it's not proper.
the connection may not be
Connection
proper.
will be-
I'll take it again. So you check in both the directions. Any one of the direction is glow, both the direction is not glowing, just leave it, I will review it. So if it started glowing, you just need to keep it like this and paste it. Icon. Whichever direction is good, just keep it at this and stay. So is the leading window testing.
Yeah. One more. எப்படி வேணாலும் பண்ணுங்க. It should be proper.
Yeah, it is there. It is there.
Coming up? Yeah.
Yeah. No problem. Like you can hold it explore.
Sir.
Contact your opposite words.
Put some tape on it. Yeah.
Fine. Not coming continuously, sir.
Yeah, continue.
There is some loose connection. It's not property, but it's not loose connection. It's not an issue. Don't worry about the loose connection.
Sometimes it's coming.
Yeah, that's it. That's fine.
See? नहीं है, yeah. Once it started, you just have to try to always pull it again. Because it is going out.
जैसे है यार, जैसे रो नहीं रहा है।
So it's working for everyone?
Sir, we can roll here.
Yeah, that's your turn. Don't change the order. go to the next one?
Yes. With the help of the light you can write, even in night. Day and night concept, yeah.
So you could explain this one, this next one. This is your other experiment, right? Actually, the setup is you need to have a scale or a stick. Okay. You need to have a scale or a stick. You need for a weighing balance, right? Similar setup you need to do it. You need to tie a rope in the middle and you can tie it to some wire. And at the two ends, you connect two balloons. Okay? Adjust the weighing balance in such a way that when both the balloons are in a full blown state, it should be balancing evenly. Okay? Otherwise, using a pin or something, if you burst one balloon, the other balloon which has air will go down, this will go up. Okay? Because like before this, it should be going like when something goes up, it has less weight, sort of things knowledge they should have. So previously if you would have done that experiment, this they will easily understand it. They themselves will say that no, yeah, balloon air is from Mars and all that. They themselves will start saying it. Correct? For this, you require two balloons and stick or a scale and thread for tying the balloon and reach the scale up. No time. I think like this, like you want to try it out or you can do it, right? Or like if you have time, enough time at the end, like you can do it like
We have learned it. But it is different.
you know the make the finger right?
Not like that, but similarity of that. We just need to open that.
You can open
Yes, then
That's fine, right?
we have
Now you know how to make it.
Yes, sir.
spin wheel, yeah.
Okay?
We have done.
Yeah. See. So explain first. I'll just help you. You know how to make this, okay? Fine, then you don't need to spend time in making this. Once, okay, assuming that the wheel is ready and it's with us and it's rotating, once you keep it in the other time, it's rotating, everything is happening. So, what you will teach to the kids? How do you ask the kids to do the experiment? What you can ask the kids to understand from this?
Yeah, how we are able to
Everywhere, air is everywhere.
But it is related to this. Will it run in a static air without a
No,
moving air?
moving
So
air.
air is everywhere. I mean, air it works on air, but air is everywhere. Logic was applicable to it.
Wind direction of the wind you bring.
Yeah.
You ask the child to run. When the child runs,
Yeah.
it starts putting
Yeah.
Start rotating,
When it starts
rotating.
running,
Automatically
there's a
it will rotate.
it's not static air, but like it will be taking
Moving
moving
air.
air. So it starts rotating.
Rotating.
Okay. Which direction the wheel will rotate? This setup.
Clockwise direction only.
Clockwise.
And just look at this wheel, look at clearly, and clockwise means this direction, right?
Yes.
Anti-clockwise means this direction, right? Look at the wheel clearly, and tell me in which direction it is.
Anti-clockwise, because the holes are like, the openings are on this side.
Go to anti-clockwise.
Clockwise
only, sir. That's the air block in that closed part and then it will rotate like this.
So how many were clockwise, how many were anti-clockwise? Anti-clockwise? Okay. Clockwise. Anyone can explain like why it is clockwise? Clockwise means it should rotate in this direction.
Yes.
Yeah. Why?
Opening ends, the closed ends, the air will struck and then it will rotate.
This end, right, will be having less cavity, having less gap. This end will be having more gap. So as far as the air comes in, it will be falling under this area, this area, this area, this area, this area, this. If you take one pin, if all the things are similar to that, you take one pin and the air will be falling over here. So this will collect all the air and pass it on to. So it will, yeah,
Okay.
it will be like rotating anti-clockwise. Okay. So if you want to make a leaf rotating clockwise, what will you do?
Opposite direction of that flap.
Yeah, that instead of using this, you need to use this shape. Got it? So you can ask the kids to make one anti-clockwise as well as clockwise. Or you can do both the shapes, clockwise one, anti-clockwise one, and ask them to experience it. What you can ask them why it is happening. Okay. So everything that no need to be a proper experiment. Even origami, whatever you learn, that also can use it. You have cups, right? How many cups you have? So whatever cups you are having, can you build a taller structure with that?
No, it will go.
Maximum 10 cups you can use. Maximum 10 cups.
PPT.
You need to build a taller structure out of paint. Yeah. That's your option. You can arrange it in whatever way you want. It should be taller. This is not horizontal. It should be standing.
Balloon. Unique. Finally there.
So you have less cups. You want taller structure. You need to use the cup effectively to make it taller. Your option. You can do whatever way you want. It should be taller. Maximum you can use 10 cups. 10. Generally I can use that. Other than that, I can use.
Not the decoration. You four cups. Actually 4 cups. Hey, don't laugh.
This was a structure we saw in the picture. Okay, and with this we have achieved 4 layers into 4. There are other structures like that is 1, 2, 3, 4, 5, 6, 7. Okay, and one more thing is that surface having left side, so it should be able to withstand. Even if you get 2 more layers for it. So when it comes here, it should be standing.
There should be standard. You will. Don't breathe.
Okay. So this is like height is little bit less. So if you are having enough, you can even if you put some duplicate also, it will stand. Structure will withstand. And here it's a mix of technology and visuality. This is like, but this is not a favorite. For this, you can what you can do, you can either take it to do or another to do to some extent, or you can use some span for a strategy. So it should withstand actually. That's our conditions we can keep adding it. So the thing is we can engage them is to make a different structure. Instead of copying the same structure, each one is to do a different structure. Other than that, each one will be having their own logic to make them higher as well as stable. You can grow it into this. The other one, square circle. Here, like we are educating the kid to have a sense of shape. Okay. Sense of shape means like you can use a sharp to cut the square of different size. Okay. Initially, your square difference can be like this actually, smaller one and bigger one. On seeing it, you should be able to tell, yeah, this is bigger and smaller. Okay. And the next level, you can increase the complexity. Complexity means by making the square more or less similar size. Again, still you can do much more complexity by making just little bit different. If you notice clearly, there is no identity. So at a level like initial first level should be use the square in a very distinct shape, distinct size, and the second level just reduce the difference little bit, and the third level make the difference very crucial. So on seeing both the shapes, you should not able to see the difference. So to make the difference, you need to compare by keeping the both the squares together, you need to do the comparison. And sort of thing, generally, the kids is able to identify which is bigger and smaller. Okay? Just sort of starting with the smaller one, and you can just keep increasing the complexity. The complexity is different, very distinct sizes. Like suppose say 5 centimeters and maybe 10 centimeters. It's very specific. Then 5 centimeters and 7 centimeters. It's okay. Then 5 centimeters and 5.5 centimeters. That's very critical. Don't keep it in mm level and just 5.1 mm. It's about, after that you also won't be able to distinguish which is bigger and smaller. So you can, the best way to get a custom size square is always like doing it manually. Like you need to mark the value and cut and create the shape. And also, for the same thing, you can do the sorting. Sort the squares in a ascending order or descending order. Bigger squares and smaller squares sort of thing can also be two. So for that, at least from 5 to 10 shapes you need to have. Okay. next is classify living and non-living things. For this activity, you can give a newspaper to the kid and ask them to cut the shape, cut the object, like whichever is living thing. You can ask them to cut all the objects and classify it. If it's a living thing, put it in a living thing stuff. If it's a non-living thing, put it in a non-living thing category. Okay, you can ask them to do it. Post to this, you can take each one object and get the justification from the kid itself why a kid has chosen this particular object for living category or non-living category. Okay, so with the experiment, they will be knowing like how they are perceiving your living and non-living of things. That kind of differentiation you can bring it up. Yeah. Yeah. So maybe for that, what you can do? Not experiment is not required. This is an experiment. Okay. You can just give some sense that if no need to a complete description about non-living thing and living thing. Yeah. Okay. Living things can walk, move from one place to another place. Non-living things can't move. Some kind of set of differentiation you can give them. That through which the kid can understand, or else you can give a story. Okay, so rain is coming. Some kind of story is in the rain is coming, like living thing and non-living thing are there. So living thing moves to under a shade also, under a shelter, so it got saved. Non-living thing stayed there and it got sort of a story you can build up initially. Post to that you can ask the kids to classify, and for the after classification you can take each and every object and get the explanation for the kid. So for a living as well as non-living, for everything they need to give the explanation. Everybody is having or only nobody? It says that it's a habit. Already you did it. So, just that I don't want to break. So, here the concept is, if you add meat to the soda, it will react and start emitting carbon dioxide rapidly. Okay? So, that's all like there is a mistake in it that you should not swallow, if you swallow milk and drink some any soda item like Sprite or soda or Pepsi or Coke, it will create some issue. It could be a serious issue. So that thing is it. So we are using that thing for our experiment. So take a soda, okay, and don't shake it before doing the experiment as given to me now. So we need to remove it. Open the cup and put the put the milk 2-3 minutes to the water and close it with a balloon like this. And once you shake it a little bit, so the balloon will start. I just take a little bit of soda for that to this blower come. If you are using full soda, maximum the balloon will burst, or else like you will get a bigger blow. Okay. So if you want to try that, you can try it, or like if you not like. So you can mix it here, like people can take a mix and pass on and try.
For having some.
So you can use any milk flavored candy like this.
Can we
Don't
use
have
milk?
water.
Maybe you can take it home and test it.
अच्छा है यार ऐसे नहीं शेक कैसे no it is only better for mango but mango
Soda or water? Soda. you can do the experiment. Like if you want a bigger balloon or you need to use full soda or more soda. Just take a little bit. You need to use more. So here they will use full water. So with this scenario, you can with this concept, like adding milk to a soda, you can do so many experiments. One is this, and another one is like other option. You can use a white sheet, okay, and use different colors to the soda. I mean, you can use a food color, okay. Normally, soda will be like transparent color. If you add a food color, I mean, you need to use some dark food color like this. And once you use it, whatever eruption is coming out, right, the flow will create some black. Sorry? What is it? Yeah. You need to use soda and milk. Along with soda, you need to use food color. Okay. So, if you use just adding milk to a soda, it will just create bubbles. If you use a food color, that whatever bubble is coming out, right, it will be the colorful. Like in that, it will create a collage kind of thing. If you use a water paint, there's a separate paper for water paint. It won't absorb the water. It won't blot the water. If you are using a paper like it is good, that structure won't get disturbed. If you are using a regular thing, it will absorb and it will, the color will get spread here. And similar to the background. Using plate, you can just build a hill kind of structure. Inside that, you can keep a cup, paper cup. So, to that paper cup, you can put some milk, food color, and then if you add soda, the same bubble will come out. If you are using orange color and red color food color, it will be good actually. So it will look like eruption from volcanoes, lava is coming out from volcano. So this is the structure. You make a kind of structure, in that just give me some paper cup, and then you can mix the color and soda. Can you move it? So, similar to living and non-living, you can have animals and plants. Okay, it will be like adding much more complexity to the living and non-living classification. Okay, so that living and non-living is done. Living things you can take it as a separate thing, and you can subclassify into plants and animals. Here also the same phenomena, like you need to explain why you need to ask questions like why they are classified as a plant and why is an animal. Okay. Crystal identification. So you can have like whatever crystals you are using for preparing food now, always use that crystal like salt, sugar, jaggery. Okay, salt itself from like powdered salt and rock salt you can keep it, and sugar itself that big size sugar will be there, pure sugar. That as well as smaller one you can use. You can give them different, almost some 5 to 6 crystals you can keep in front of the kid, and you can ask them to classify and ask them to identify, not classification here, it's identification. What is sugar? You can ask them to taste and say what it is. And even like sugar, you can subclassify it. The bigger one, why is bigger in size, and yeah, so in general you can keep asking. And the jaggery, using colors they can differentiate. Jaggery?
No, jaggery is considered as crystal, so
No, getting into too much, no, don't go in depth. Just look into outer view. I need to add, I need some more items actually. That I have added jaggery. So similar to that, you can keep adding. Even the jaggery, crystal forms are available. Jaggery, too many. But don't worry about whether it's crystal or just classification. They are like you are giving the sense of taste and sense of smell, but then sense of smell you can do some exercise sort of thing. So eat the monkey. This is another experiment with a monkey and fruit toy you can play with them for a math category. So you can build a scenario for addition and subtraction learning. The 3 monkeys are there, and you can, by giving some 10 fruits to kids, you can ask them to feed the monkey one by one. Okay? If you are feeding one banana to one monkey at a time, at the end, like you are left with something. Well, left with 1. You can do all this setup. You can keep all kind of complex mathematics there. Subtraction, addition, everything you can do the logic using it. It will be easy for them, and you can relate it to a real-time scenario for the kid. Like monkey, always like people want to say monkey, it will be like big alert and start listening. And food, sort of things, you can. So with this, you can do addition. Or like suppose saying subtraction, yeah, you have given 5 bananas and 3 monkeys are there. You need to give 1 banana to each monkey. You can ask the kids to give 1. Okay, how much is left in your hand? That's the thing. You need so many combinations. You can do all the arithmetic in this concept, but you need to build a story behind it. But so you have any doubts?
so we have got this animal
No.
And modeling
You anyway you're going to use it actually. I didn't this logic is of that. Instead of telling in basic actually. Yeah. I can't cover that. I start each one take at least 1 hour. At least 1 hour at least we need to complete all the grades. So we can cover all these 6.
This we can also use for animal and plant classification.
Exactly.
identification.
Yes.
And this one is a play?
Play for So I thought like everything I thought of doing all the 49 as a all the 39 as a hands-on, but it's taking more time. I can't cover it in a single day. So that's why it's rush up for it. So now I think like you'll be getting clear view of all the things. So you can just try it.